Hello everyone, welcome to the fifth lecture of this course. And today's lecture will be kind of a summary lecture where I will be talking about a few little things, and mostly I will be summarizing all the things that I have discussed in the first four lectures. And after this lecture, we will delve into the more intermediate and advanced stuff. In the first section of today's video, we'll learn about the features of Pluto. We have seen all these features in different videos and they were all scattered. So I just wanted to quickly go over them and tabulate them once in this lecture so that if someone is understanding how something is working, they can refer to it here and it will all be tabulated in one place. Okay, so the notebook cells. So these rectangular blocks are called cells. Will only allow one expression at a time. Otherwise, use begin and end. So we have seen this. Do we can do x equal to 1, y equal to 1. This will run, but this will give you an error. So we have to use begin and end block to run multiple expressions. So we have seen this before. The second thing is updating a variable will affect all the cells. So suppose I am printing the value of x here, and if I am updating the value of x to 3, it will automatically affect this cell also when I am updating the value here. So this is a very nice feature. It will just create a map by its own of all the cells which is dependent on this variable x, and whenever this variable is getting changed, this will only run the cells which are dependent on this variable. Other cells it will not touch. Okay, so for example, you can see that I am changing something here and here. So if I run it, it will get reflected here, and unless I run it, it will not get reflected. Okay, the third feature is you can use Pluto UI, which has interactive buttons and sliders. So we have seen how to do it. We can use it using this command using Pluto UI, and it will install the Pluto UI on this notebook itself. So this is another feature. It has a package management system built in, and which is standalone. That means it will work as a separate package manager, and it is not dependent on the package manager that Julia provides by default. So the packages that you install in your notebook will only work inside this notebook, and this also helps in the reproducibility of your notebooks. So when you are sharing your notebooks to some other people, when they run this notebook, these packages that you are installing in your current notebook will also get installed in their machine, and they will match all the versions of the package. So it will enable them to run all your codes perfectly. So all of these things are taken care in the background, but we don't have to worry about anything. We can just share the notebook. So that's another feature. And let's see one of the example of this photo UI, the bind keyword. We can bind, and we can assign the value that we choose from this slider to this variable part. To check it, we can just print the variable and we can check that this is updated. So another feature of Photo is that it can use standard markdown. So we have been using this since the first lecture, but I haven't talked about it really. So all of these headings, subheadings, and bullet points that I was writing, that was using markdown. So it is very useful to write these comments using markdown because it not only shows all these headings and subheadings in a pretty way, but it also helps us write mathematical equations, show links and images, those kind of things. Again, this is not a course about markdown, so we will not be talking about that. If you're interested, we can just go to this page and this will have the introduction of markdown. This is again a fairly lightweight markup language, and this is new also. It started in 2004, and you can write headings, subheadings. We can do bold, italic, monospace. We can write code. We can do this list. Then we can add links, images. All of these things can be very easily done in Markdown. That makes our notebook much more interactive. So I will not show any details. I will just show that to write Markdown in Pluto, you have to write it between this MD quotation mark. So if you just write something here, it will be treated by Julia as a string. But if you write MD just before starting the first double quote, then it will be treated as markdown and this will be rendered by Pluto. So we can add equations here, which are very handy. So here you can see this is taking the value of our variable that we have, sorry, this variable that we have stored. So it will update by itself also. Okay, we can write LaTeX, then it will run as LaTeX also. So I think that wraps up all the features of Pluto that I wanted to talk about. So let me finish just by saying that Pluto does not allow redefining a variable. Okay, so that means that if we have defined x equal to 7 here, and if you want to define x equal to 5 at a different cell, then Pluto will only work with the latest definition and it will actually disable the previous cell. So with that, we can conclude this section and let us go on to the next section of today's section. Now we'll learn about recursions. So let me create a subheading. So what are recursions? So in programming, recursions are a case where a function is calling itself directly or indirectly. So this involves a technique where the problem is broken into multiple self-similar but smaller problems, and that can be solved by repeating the same logic. Okay, so that means we have seen how to write functions. If we call the function in its body, so the body of a function is the set of code that you want to reuse, then it is called a recursion. Okay, so a function calling itself in its body is recursion. So some problems that can be easily solved with recursions are finding factorial of a number or finding Fibonacci series. Okay, so we'll see. So we don't need these anymore. So let us first tackle the problem of finding factorial of a number. Okay, so we know that factorial of a number n is defined as n times n minus 1 times n minus 2 times n minus 3, and it goes on till 1, right? So this we will do only for integers now. So let us write a function that can implement this first. So we will just do a simple function, and later we will try to modify this function in such. We want to find the factorial of a number, so we need one input, that is the number, and then we want to multiply everything from 1 to n. So we can define a variable fact, and we can run a for loop that will run from 1 to num, and this for loop, each iteration when it is traversing from 1 to the number will multiply the fact parameter with the current number. So for the first iteration, this is 1, this will become 1. For the second iteration, this was 1, this will now become 1 star 2, so 2. Then in the third iteration, it will become 2 star 3. So this is tackling it from the lower number up to n, and this for loop will run up to num. So we have specified it as number. So this for loop will run up to number, and it will multiply all the elements that it is running over. And at the end, we are returning the value of fact. So this is our function. So let us check. Let us call it with 1. So this should give you 1. Let us call it with 5. This should give you 120. Let us call it with 6. This should give you 720. With 4, this should be 24. So the function is working correctly as we expected. Okay. So one thing that everybody knows, that factorials can get large pretty fast, and this fact here is actually a int64 number. So if you check type of this, you will see that this is a int64. So if you give it a large value, it will actually go out of the bounds of the data type. So what we can do is we can make sure that either this is a float, or then it will work, or we can call it int 128, then also it will work for some numbers, but this might not work for larger values also. So it is safe to define it as a float value. Okay, so let us put 5 here, where we have a known answer. So now the question is, how do we tackle this problem using recursion? So let us write another function. Let us call it factorial recursion. Again, this will take one argument, that will be the number of which it will try to find the factorial. So we can see here that the logic is factorial of n is n multiplied by n minus 1, n minus 2. So we can use this property of factorial, that is fact n is equal to n times fact of n minus 1. So we can use this and use the initial condition that factorial of 1 is 1. So this is what is I was talking about when I was describing what recursion is. So this problem, we can subdivide it into a smaller problem. So here we have to do the iteration for n times. Here we can do for n minus 1 times. So we have divided into a smaller problem, and we are using the same logic. So what we want to do is to incorporate these two statements in our function. So first, let us do the one case. So if number is 1, then we know that the value of fact 1 is 1. So we want to return 1. If that is not the case, then we will say that the function will return this int, which is number in our function definition, times it will return the function definition, function name for number minus 1. And this will give you an error because I forgot to end it. Now it will run. Okay, so I hope everybody has understood the logic behind this. So this function, factorial recursion, is calling itself within its body, and that's why it is a recursion. And The logic here is this: when the number is 1, we want to return the value of fact1, which is 1. And when the number is not 1, we want to subdivide the problem and return this value. So n star fact n minus 1. So we want to return number star factorial of number minus 1. When we are calling this function, say on 3, it will work if I type it correctly. So 3 factorial is 6. So let me just walk through the execution process of this function so that you understand it completely. So when you are calling this function using 3, this will run this code. So it will check if the number is equal to 1. So it will say, no, the number is not equal to 1. So it will return the number, which is 3 star factorial recursion, which is our function, and number minus 1, which is 2. Then when it is returning this is actually telling the code that this is something unknown. The value of this is unknown to me now, but I know the function, so we have to evaluate it. So when it is evaluating it, what will this become? So factorial recursion 2, again, number is not equal to 1. So this will return number star. So just for this statement, it will return number star factorial recursion 1. And since we'll be getting the return value from this original call of the function, then this is also there. So we have to, this will carry forward. So in the next run, it will again carry forward. And now when this function is being called, you will see that the value being passed is 1. So this condition will be true and it will return 1. So you can see how nicely it gives us this pattern that we described here, and this is actually matching with our value that we wanted to find. So with the value of 3 factorial for this particular case. So let us check for another case. We will see that this is also giving us the correct answer. Okay, so that's how you can use recursion to write a function where we can find the factorial of a number. So we can also look at another example for recursion, which is to find the numbers of a Fibonacci series. So this is a sequence where you start with two numbers. It can be 0, 1 or 1, 1. So you start with 1 and 1. So the next number will be the summation of the previous two numbers. So here it was 1 plus 1, 2. Now it will be 1 plus 2, 3. Now it will be 5. Now it will be 8. Now it will be 13, 21, 34, and it will go on like this. So we want to generate this pattern using recursion in our function. So first, let us again see how we can do it without using recursion. Let us call the function Fibonacci simple again, and let us give a number. So this will signify how many elements this will generate. So let us store all the elements in an array. So we have defined the first two elements, 1 and 1. So again, for the generation of other elements, we will do a for loop, and this will go from 1 to n minus 2. sorry, this will be number minus 2. Why? Because we have already defined two numbers, so we only have to get n minus 2 more. So what it will do is it will calculate a new number which will be ARR end ARR end minus 1. So here end is just specifying the last element of the array, and n minus 1 is specifying the second last element of the array. Okay, so this is another new syntax. End means the last index of the array. So ARR end will give us the last element stored in the array. So essentially, what end is? It is a number which equals to the length of the array, and it will change dynamically as the array grows or shrinks. Okay. So now that we have generated the new number, we have to append it to the array. So we can do one thing, we can make it a vector, and we can say that our array variable is getting redefined to ARR and new number. Okay. So this syntax we have seen many times in the previous classes. What this will do, this will actually append the new number to this vector. So again, we can run this function. Say we want to get 5 elements. Okay, we forgot to return something. So what we will do is return the array, and you will see now the function is running, and you can see that it is correctly giving us the first 5 elements: 1, 1, 2, 3, 5. So let us do it up to 10, and now you can see that it is again giving us all the elements correctly. 1 plus 1 is 2, 2 plus 1 is 3, 2 plus 3 is 5, then 8, then 13, then 21, then 34, then 55. So this function for finding the Fibonacci series is working. Now let us see how can we do this in using recursion. So what the logic is here? So our function, so suppose we want the nth element, this will just be the summation of n minus 1 and n minus 2 element. So here the function number was actually giving us the array, but here this function is actually referring to the nth element. Okay. So with the factorial problem, we divided it here also. We have to do it. So we are dividing this problem into same but smaller problems, and we have to have two initial conditions also, that the first and second number will be 1. So let us write this code again using the recursion syntax. So it will take a number and this will return the Fibonacci number. So this function will just return the number in the series, not the whole series till the number, not the whole series. I think that is sufficient. So what we have to do, if number is equal to 1, then we will return 1. Else if number is 2, then also we will return 1. Else we will return function number minus 1 plus this function number minus 2, and we have to end the if block again. Okay, so we can run it, and let's say we want to obtain the 10th element, which was 55. We have obtained it here. So if we run it, you will see that we are getting 55. So let me again explain the iterative steps for a smaller number, say 4. So this will be 3. So what this will do is this will see that the number is not equal to 1 or 2. So this will return 4 minus 1 is Fibonacci recursion. This will return this statement, which is Fibonacci recursion number minus 1. So 4 minus 1 is 3. And Fibonacci recursion 4 minus 2 is 2. Now, in the next step, it will try to evaluate both of them. Here, it will be again not equal to 1 or 2. So it will return Fibonacci recursion 3 minus 1, that is 2, and 3 minus 2, that is 1. Now, this part is satisfying this case where the number is equal to 2. So this will just return 1. And in the next step, all of them are satisfied in the first case or second case, number equal to 1 or number equal to 2. So it will just be 1 plus 1 plus 1, which is 3. And this is our answer. Okay. So you can simplify this just by combining these two if and else if comments. Since they are both returning 1, you can write it like this also. And this will still run. Okay. So I think we have seen enough examples of recursions. So let us move on to the next section. I have not talked about these operators, so let me quickly do that. So these are called Boolean operators or AND or operators. You have seen this when you are doing Boolean algebra. So Boolean AND in Julia can be written as ampersand sign, or also it can be written with two ampersand signs. Similarly, Boolean OR will be written with a single pipe or double pipe. So both of these will work, but these double ampersand or double pipe symbol, these are preferred because they will speed up your code. How? I will discuss that in the next section. And in Julia, these are called short circuit operators. So by this, I mean this double ampersand and double pipe symbol. So what is the use of this? So let us define one variable a1 as true and another variable b1 as false. And if you want to do Boolean AND or Boolean OR operations on this a1 and b1 variable, we can do this using these operators. You will see true and false will be false because similarly a1 or b1 will be true. You can also check that you can use these double ampersand and double pipe symbols also. So what can you do if we want to act them on a array? Again, this is very simple. We have seen examples of this in most of the videos. So I have defined two arrays, A2 and B2, which all contain Boolean elements. And suppose I want to do bitwise AND OR operation. Okay. So bitwise AND or bitwise OR, they mean that they will act on each element of this array. So this is like element-wise operation, and we can do that easily the dot syntax. So you will see that A2 dot ampersand B2 is giving bitwise and operation between the elements of these two arrays. So true and false will be false, false and false will be false, true and false will be again false, true and true will be true, and false will be again false. Similarly, you can check that this will also work, and you can also check that these two will be equal. So what you have to do is you have to wrap them in a parenthesis so that the equality operators work correctly. So you see that these are also true. Similarly, let us check the bitwise OR operation also. You will see if we do not pass the dot part while doing this OR operation, this will not work. So now this is doing element-wise Boolean OR operation. So you will see true or false is true, false or false is false, true or false is true, then again true. then again true. And this is doing this correctly. So let us also check the other version, and we can also check their equality. So that's how you can do Boolean AND or Boolean OR operation. Okay, so we have actually seen one of the Boolean operators in previous video, that is the Boolean NOT, and this is given by this tilde symbol. So if you write tilde a2, this will not work because this is designed to work on a single value. If you want to do it on array, you have to do it like this, and with the dot syntax, you will see that it has completely inverted the A2 array. So it was earlier true, false, true to false. So now it will be false, true, false, false, true. And you will see that this is giving us the expected result. Okay. So I talked about this as inversion operator, but this can also work on Booleans as Boolean not. Okay. So now let us come to the section while we are here, and let us discuss why these operators are called short circuit operators. Okay, let me define this part. So in programming, a short circuit operator is one of the operators which is evaluating a logical expression. So like this or like this. So anything that is evaluating a logical expression, but this will stop the evaluation as soon as the result is known. So what do I mean by that? Suppose we have two, sorry, you cannot write or, you have to write it like this. So suppose we have this. You can change them like this also. So suppose we have this case. So here, what the programming is doing is that it will go through all of these values, okay, and then it will calculate the Boolean OR of all of these values. So everything here is considered. You see that this is giving 11. That means it is adding the value of this expression true to this 10. Now, if we do it with this double pipe operator, then this becomes a short circuit operator. Why? Because it will stop the evaluation as soon as it knows the answer. So, for example, here the first thing that it encounters is true, and the programming language knows that when we are doing Boolean OR, if anything is true, then I don't need to evaluate the rest of the information. Okay, so we can just see the first element and we can decide that yeah, it will be true, so I don't need to look at this. So this will still give you the same answer, but you will see that this part is not being executed. So what is happening here? Let me show you another use case. So suppose everything is false, then you will see, since everything is false, it is going over all of them, expecting a true value where it can know the evaluation, but it never gets that value, and then it obtains this expression that println this will print, and you will see that this is being printed. Now, so let us just change this from false to true, and you will see that this has stopped printing this. Why? Because is true here. So whenever the program is evaluating this expression, this will encounter a true and it will say, okay, I know this will be true and I don't need to look at the rest of the expression. So it will stop. So this kind of operators which stops after it knows the value of the evaluation are called short circuit operators, and these double pipe symbol for representing Boolean or is one of them. So it can be done with this AND operator also, and you will see, since our first value is false, it knows that whatever I write after it is always going to be false. So it will never get to this and this will not print it. So what we can do, we can make everything true. Then only it knows that I want to see if there will be any false in the expression so that the evaluation can be confirmed. If not, I will just go over all these values, and if it is true, then I will come over here and print this. So now you will see that this will print. So I hope you have understood the role of this Boolean and OR operators, and we have also learned why these are called short circuit operators. Okay, so let us move on to the next section where we will be talking about multiple dispatch. So let me create a subheading, and let's see what multiple dispatch is. We have talked about it in earlier videos, and this is one of the key contribution of Julia in the programming paradigm. Okay, so let us begin. So multiple dispatch is a programming feature where the function's behavior will be determined at runtime based on what type of input we are passing to the function. Okay, so multiple dispatch will look at all the arguments, not a single argument, and this will choose based on the type of all those arguments what definition of the function to use. So let us see this in action. Suppose we are writing this small function f, then if you pass value x, and suppose we want to get the double of this value. So you will see that the REPL will tell us generic function with one method. So if we pass f1, you will see that it is giving us the value correctly. So f10 will also give us 20. Now, this function does not cover all the cases. Suppose one mistakenly is passing a string to this function, then what will happen? This will give you an error. It will say that this is an error for the method and no method is matching the star function for int and string. So the star function that we are using in this function f is not defined for int64, which is this 2, and the string which is we are passing as x. So what one can do to bypass this error is that it can give another definition of the function, say fx And say when we are passing string, it will print only that. Okay. And let me put a help message also that we have passed a string and we'll print the string that is passed here. So if we run it, then you will see that we have obtained another error, which is saying that there are multiple definitions of f. And we have seen in this Pluto notebook that you are not allowed to define a variable or a function multiple times. So what it is doing is that it is seeing this function and this function exactly identical thing. Okay. So why this is happening? Because we have written them exactly the same. So this is also f of x and this is also f of x. But we didn't want to do that, right? We want to get this value of this function when we are passing number. So use this method when we are passing number and use this method when we are passing strings. Okay, so how can we specify that? So let's leave this function alone. Let us look at this one only. Okay, so here one thing that we can do is we can specify what will be the data type of this argument. So here if parenthesis x means x is one of the argument of the function, and we can specify which data type this will have. So if you do not specify anything, then that will mean that x can take any kind of data type. But if you want to say, suppose, specify that this will only have strings, we can do that like this with the double colon syntax. So x double colon string will mean that this function fx is printed and passed a string comma x. The function which is defined like this will only accept strings. So let us save the notebook, and now you see that all the errors have vanished, but this thing here has changed. It is now saying that f is a generic function, so the name of the function is generic, but it has two methods. What are the two methods? One is this one, which we are going to use when we are passing a number, and this is another definition of the function, or then another method of this generic function, which will work when we are passing a string. So let us check that. You will see we have passed the string 2, and if we run it, you will see that this has correctly printed this. So what Julia is doing under the hood is this is looking at the arguments that you are passing to the function, and then it has a map of what the methods that are defined within this function. So it will look at the argument and it will see that, okay, this is a string. So let me look at the definition of this function f, and let me see if the user has specified anything where this function will be taking a string argument. And then it will find this definition of the function, and then it will say that, okay, this is the command that I want to use when the user is passing a string. So it will use the println command and it will do this printing. Now, when we are passing 10, then it will again check whether we are passing string. So it will see that, okay, no, 10 is a int 64. Then this is not the correct definition of the function. So it will fall back to the generic definition, which is not specifying any type of x, and then it will just print 2 star x. So is this complete? We can check with, say, suppose we give it a character, then also it will throw an error. So this is another case. So what we can do, is define another method for this generic function f, and this time it will take a character, and we will write that we have passed a character, and it will see that again the error is vanishing. And now this statement says that f is a generic function with three methods. Not earlier it was two, now it is three methods. So let me rerun all the cells. Okay. So here it says f is a generic function with three methods. What are the methods? This is the first one, which is generic method. This is the fallback method, as we have not specified any data type of the input variables. Okay. So this is another method where we have specified what to do with the function if it passes string, and here we have specified what to do if it gets a character. Now you can see that these two are doing almost the same thing. So we don't need to define it in two places. We can check that. So we can check in one definition whether it is passing a string and character, and then just print a similar statement. Okay. So how can we do that? We can write this union curly braces string comma card, and let us modify the message also. And we forgot to end it. Yeah. So now it is saying that the function has four methods. Okay. So we will stop these two methods temporarily. And so let us first see what this union thing is doing. Okay. So x colon colon any type will tell the code that this function is expecting that exact type of input. Now, if we do this union thing, that just means that now this variable x can expect a union of string and character. Okay, so what will happen is that you can pass either string or a character, and this definition of the function will satisfy both those conditions. So we can see, we can comment these two, and we can run, and you will see that it is still working. So here it is still saying f2 is passed a card or string to, and we can write this also, and you will see this is working also correctly. Passed a card or string C. So you can use this union to specify that our input parameter is gonna take multiple kind of data types. Okay. So another useful case will be to fix your function for, say, only integers and floats. So you can write in 64 and float 64. So this will give you a union of float 64 and in 64. And if you use this in your function, it will only pass those two kind of data types. So let us write another definition of this function. Say Say we want to print not 2 star x, but x square when we are passing either in64 or float64. Now you see that this value has changed because 10 is a in64. Similarly, we can also see this will also give you the square of the number that we have passed. So this definition is not being used. Okay. So the generic method, which is accepting all the data types, will be evaluated at last. So the program will check for this specific methods. So these definitions and this definition where we have specifically told the instructions for certain data types. They will get checked first. If they are matching, that will run. If they are not matching, then only it will go to this fallback method. So this is the essence of multiple dispatch. So let us do another case where this fallback method will be used. So this is only accepting in64 and float64. So if we do f of 10, it will give us 100. So 10 was already done. So let us uh, do f of 4, this will be 16. But if we pass, say, in 16 of 4, then it will print 8 because we are passing a in 16 data type. Then this method, this definition of the generic function will not get triggered. It will go to this fallback method, and that will let the program know to execute this expression, and this will return the value 8. Similarly, int 1 to 8 will also not work. You see, it is returning 2x, but in 64 and float 64 are returning the square of the number. So this is the essence of multiple dispatch, where you have a name for a function that will be called a generic function, and you have defined multiple definitions based on what are the different data type that the function can expect. And the program will act in such a way that when you are running a code and it is encountering that particular function, then it will look at the type of all the elements and then it will choose which of this definition of function to use. And if it doesn't cover all the cases, then it will give you, of course, an error. But if you have written it perfectly, then it will cover all the cases and you will see that your execution of that function is following the different methods that you have specified for different data types. So this is a very strong feature. That means that you can define all of these different methods at different locations and still they will work. So suppose you have a code where you are writing multiple things and this has become 10,000 lines. So suppose after doing some testing, you have found a bug that your function, one of your function is not working for one particular data type, one particular edge case, then to fix your code in other languages, what you have to do, you have to revisit the function where you have written its definition. If the same function is written for different objects at different location, then you have to revisit all of these places one by one, and you have to fix the definition one by one, or you have to go to all the places where the function is called, and you have to check your input in such a way that you do not run into those error messages. Now, in Julia, what you can do is you can go to the bottom of your code and you can just write another expression of this function, which will define a method and it will take care of your edge cases and it will fix all of your code. So that is the power of multiple dispatch, and this can scale exponentially. The Julia is only language which is supporting this multiple dispatch feature, and you can do it with R and Python also, but these languages were not designed to have multiple dispatch, but Julia is made with this feature at the base, and this works perfectly for Julia. So I hope you have understood the concept of multiple dispatch. If you have any question, so this is a completely foreign concept for those who have prior programming language exposure. So this is a completely new thing. If you are still confused, please let me know, mail me or comment in the videos. If you have any doubt, I will go over this as long as it needs until everybody has a grasp of it. So let us now check a few more examples of multiple dispatch. So remember, we have this function add to numbers, then we had in the earlier definition num1 and num2, and then we returned num1 plus num2. So we defined this function earlier, and this was working for, I misspelled it. So this was working for integer and float inputs. So what will happen if we pass this as a string? You will see that you have run into an error. So how do we fix this? We'll use the same concept as here. So let us define the function again. We'll use the shorthand notation now. If we are passing string or car, and if we are passing this as any, then return or just print don't pass characters. So will this fix our problem? You see that it will not, because again we are passing string in the second parameter. So we have to modify our definition for this case also. And somewhere I have missed, yeah, multiple columns are here, and somehow I have again just defined the same thing. So let me correct that. Okay, you see that now the errors have disappeared, and when we pass a string, this will tell us that don't pass characters. So you can look at the other case. This will also work, but we have forgot to check one of the end cases. That is when we are passing both strings. Again, you will see that this will not work. So we have to define this the case where both are being passed as string. So I copied that earlier. We'll, let us do that. And Too many columns there. Okay. So now this is the correct definition. And let me just change the message. So you see that this is again printing the correct method based on the kind of elements that we are passing as parameters to this function. So this is the essence of multiple dispatch. If you have multiple parameters and you want to tackle all of them case by case, this can become a bit tedious. But again, for those cases, it is best to write your primary function. So suppose we want to multiply two numbers. So if you don't want to tackle all the cases of characters, bools, strings, you can just say that this will work on number. We have seen this abstract data type number, and this will return num star num2. So when we pass 2 and 2, you see that it will work. But when we pass characters, it will give you an error, and it will see that no method is matching this syntax int and string. There are other ways in programming to catch error and do different stuff based on what kind of error that you have encountered. So you can tackle passing these strings for these wrong inputs using those methods, and you can just keep your function definition simple like this. Okay, so I will show you some other features also. So suppose let us comment this out to hide the error message. Okay, so let me show you another technique where you can check which of the definition of this function is being used. Okay, suppose here our add two numbers function, it has four methods. So suppose we want to see when we are calling this function, what particular method is being used. So when you are writing your own code, you can check your code and you can know what method is being used. But suppose you are using a package and they have this one method which have been written with multiple dispatch, and now you are getting some unexpected result. So if you use this technique, then you will get to know which definition of that function is being used, and you can then check the corresponding source code also. So this needs to be done in the REPL. So let me just quickly open Julia. Let us wait a few seconds for it to load. Okay, so let us define two functions. So if it is float 64, then it will return 2x. And if it is string, then this will just return the string. Okay, so now our function f has two methods, and if we run f test, this should just say test. So if we run f of 5, this will not work, and if we run f of 5.2, this will return the double of this number. Okay, so suppose in a scenario we don't know why this is giving us this result. For example, if you're using a package where the function is written by someone else, so what you can do is you can write the at which macro before the function call, and you will see when you run that, you will get the definition of the function that is being used. So this is using if where f is float 64. Now, if we do this, you will see that it is using the definition of the function where the parameter is a string. So if we define it for a number, that it will give us 3x, then our function will have three methods. And if we run 3.0 and 3, then what will happen? Consider this as an exercise. So I will just wait for a few seconds for you guys to think, and then I will run this code and we get to see the answer. So I hope you all have your answers in mind. So if you run it, you will see that when we are passing it a float, this is returning this expression 2x, and when you are passing it a number, so what this will do is it will return this 3x expression. So here, let us check what definitions are being used. So we have already seen for the float, this will use the float definition. And let us check for the integer case also. Here you will see that the definition that is being used is this one, which means that here, since we are passing a integer, this is not matching with any of the specific cases where this float and float 64 and string types are addressed. So it will call back to a more general method where we have specified the number type, which is a super type of float. So Julia under the hood decides all those things, how to rank these function definitions, how to match them. This is all done by the compiler, and this all happens at runtime. So this has very insignificant overload on the runtime of the function. That means that how many function methods you have defined for a particular function name, this will not hinder the performance of your code. Okay, so that is another plus point, and this is one of the reasons that Julia is so fast. So let us go to our notebook and let us check another thing. So for those who are coming from other programming languages, for them, I just want to write this function in such a way that you will see how this works. If you're not using Julia, if you're using something like Python or C, then for addressing all of these use cases, what we have to do is we have to do if-else statements. So if the type of x is equal int 64, and let me copy that also. If the type of y is also in 64, then it will return x plus y else if the type of x is string or car or y is car or y is string, then in that case we want to return nothing, and before that we want to print the message that this function only works on numbers. Then we want to end it and let us check. So the name is legacy. You will see that this portion is running because it is following all the types. Now, if we add, if we pass 1 and 1, it will give us 2. Now you will see if we have 1 and 1.0, then this is not being addressed by this function, and this will just not work. This will return nothing. So to address that case also, we can say if the type of this is a subset of number, and this is also a subset of number, then you will see that it will work for other cases also. So you can imagine if with only 2 inputs, I have to write this much code. Suppose I had another number, this code will explode. You have to check the typing for all other possibilities. So here you can modify this like this also. So you can use the union feature here also. So what you can do is union of string and card. So this is just asking whether the type of X is a subtype of this union type. So since this union is taking both string and characters, so if you are passing character or string, this will be a subtype. We can check this also. We can write a else case also here. So you will see this is again working. And if you pass a boolean, it will still work because this is again a subtype of this number abstract type. So I wanted this to be legacy 2. If we pass one array, then it will, sorry, I have made a typo here. Then if you pass an array, then it will not match any of this type, and this will execute this block of code. So if you are using older language like Python, C++, or anything else, so in that case, if you have to tackle for all of the data types in your function, then you have to specify them explicitly like this. But in Julia, we can just define the functions and specify what the type will be, and this will work exactly same without any performance overhead. Okay, so I think that is enough for discussion on multiple dispatch. I will just go to the next section, but I will just comment one thing, that is when you are not specifying any data type of a parameter, it can work on any elements. Okay, so that means let us define a function g, say x is x squared, that is equivalent to writing gx any equal to x squared. You will see that this will give you an error message because these two are exactly the same. But if we change it, then the language will consider them as different functions. So what is the take-home message? That is, Julia has multiple dispatch, which makes it very easy for the users to modify the logic of their code without modifying the previous functions. You can specifically mention the expression that the functions will evaluate based on the type of the parameters that are being passed to the function. And when you have nothing mentioned, this will take any argument. Okay, so the above expression is similar to, not similar, this is exactly same as this. Okay, so with the help of this multiple dispatch, Julia can determine at runtime which of the function definitions to use for a particular set of parameters that you have passed, and that makes it a very fast language. So I hope you have understand these concepts completely, and we'll go on to the next sections where we'll solve some easy problems. Okay, then we will summarize all the previous lectures and move on to the next part of our course where we'll be tackling intermediate stuff. So before that, let us do this problem solving where our goal is to convert the code written in the previous problem solving session, which were for finding perfect numbers and finding Armstrong numbers to a function. So we'll be reusing that code, but we'll make them a function. Okay. So this was long overdue, and that will give us a easy session. Okay. So let's start. So let us begin with the problem solving sessions. So we did those problems in lecture 3. So let's open that notebook. And the first problem was to find Armstrong numbers till 1000. So this was the code. Let me copy everything and paste here. So our goal is to make this a function. Okay. So we will use the code and we'll try to use the dot syntax. So to make it a function, let's use this syntax. Call our function is Armstrong number, and it will take a number and it will check whether that number is an Armstrong number. So I don't need these loops. And this end statement also that was associated with the loop can be deleted. So this I was looping over the numbers. So now we have just one parameter. So we can make it number, and this all will be number. And we can also specify that this has to be union of int 8 and 16 and 32 and 64 and 128. So it can be any kind of integer. Okay, so now we don't want these prints. Let me delete these comments also. So what this function was doing was it was getting all the digits of that number and it was raising them to the power of the number of digits. And we are saving that in this variable check exponent summation, and if this is equal to the current number, then that was an Armstrong number. So what we want to do, since we are using a function, we want to return true in this case, and if it is not, then we want to return false. So this is our function, and we can check with 1, 2, 3, and I have mistyped the name of the function, and somewhere I was defined that I have missed. So this will be number, and I think, yeah, it is working now. So 1, 2, 3 is not an Armstrong number, we know, and that's why it is returning false. And now if we pass 1, 5, 3, it will return true. Now what we want to do, we want to print everything in between 1 and 1000. So we can do that using the dot syntax, and we will just pass the unit range. So what this will do is this will give you a array of true and falses. Okay, so if you use this array to index on this element, you will get a list of all the Armstrong numbers till 1000. So we can do up to 10,000 also. and you will get some new observed numbers. So what we are doing here is array indexing based on true and false values of the index. So let me quickly show you that example. We can hide this function for now. So I don't remember if I have shown this earlier. So normally we do array indexing like this. A1 means the first element, A2 means the second element. Similarly, A3 will be the third element. But you can index the array also like this. So you can pass an array here. Suppose you pass 1, 2, then this will look at the first element and second element. If you pass 1, 3, it will be 1 and 3. So you can change this example, say 199 and 30, and you will see that these values are getting changed. So when you index an array by providing it with another array, then it will find the elements of the array based on the elements of the array used to index A, and it will only return the elements which were present at the indexes which are defined in the past array. So that means if you are passing 1 and 3, this will treat each of these as the index where we want to get the element of this array capital A, and it will say that the first index is this one and the number saved there is now 10. So it will see that and it will look at this index and return the value 10. Similarly, here we are looking at the third index, it will set the value 30. You can also do it like this, and then it will look at the second element also and return 99. So you can pass these indexes in any order. Another thing that you can do is that you can pass a vector, only vector or matrix, which only contains Boolean. So this in this method, the array that's being used for indexing, that means the array that we are passing within third brackets, has to match the dimension of the array. So this has to be true. So if you just pass an array where the dimension is not same as A, then it will give you an error. So we have to make sure that the dimensions are same, and what this will do is it will treat this as a condition of whether to return the element in this index. So it has three elements. So true, true, true is indicating that when we are looking at the first element, we want to get that element. when you're looking at the second element, you also want to get that element. While we are looking at third element, you also want to get that element. So now everything is getting returned. If we make the first one false, you will see that it is not returning 10, it is only returning the second and third one where the index is true. So where the value of the first array is true. Similarly, let us see some other cases also. So suppose multiple of them are false, this will also work. This will also work. And if you make all of them false, then this will return an empty array. Okay, so this array indexing method was being used when I was doing this. So what this will return, so 1 is to 1000 will give us all the numbers till 1000, and what this will return is a vector of true and falses. So this is a with vector, and these values are chosen as per the return value of this function. So that means this is using the dot syntax. So this function is being passed each element which are here of this array to this function, and it is returning true or false accordingly. And this is the return array. Now, when we index the original array, which was this, with this part, which is just giving us this bit vector of true and false, it will return only the elements where this bit vector is true. So, okay, so dimension is mismatch. Here it is 10,000, here it is 1000, so we can make it 1000 and it will work. So this is the array indexing method that I just explained using this example. So you can index arrays like this also. So with that, the first problem is done, and let us look at the second problem also, which will be to get the list of perfect numbers. So let me copy the code again. So this is the code. So this is comparatively smaller. So let us again use function keyword and check is perfect number. This is our name of function. And again, we have to get rid of this loop. That means this end statement will also go. Let me change the indentation so it is easier to read. Now, everywhere it was I, this has to be number, and this again will only take union of integers in 8, 16 up to 128. So what we can do is we can just write it for int64, and that is the default integer data type that is assigned to a integer in Julia. So we'll just use this one. So now let us check whether this function is working. We know that 28 is a perfect number. And I think I have again misspelled the name of the function, so let me correct that. Yes, so now if it is a perfect number, it will print. If it is not, it will not print. So we want to change that. We want to return true or false, and then we will see that it is returning true or false. So suppose you want to get all perfect numbers till 10,000, say. So what you can do is you can use the dot syntax again, and you can run this. Okay, this will be true, and you get again a bit vector where everything is true and false, which is of length 10,000. So if you just use this to index this unit range, you will get a list of all the numbers which are perfect numbers from 1 to 10,000. So maybe we can increase it up to 1 lakh, and let's see if this is giving a different result. So it will take some time to run. Meanwhile, let me copy this. I want to show you another thing. So it is still not giving us any different numbers. So let me reduce that again. Okay, so now suppose we did not have these return statements, rather we have the original. Okay, we have to give it a different name. Okay, so rather we have this println statement if the number that we're checking is a perfect number. So if we run it on say 8, then it will not print anything. Okay, sorry, we have the function name we have to change. This is with print, so this will not print anything. And if we run it with 6, then it will print the number 6. So this is another question for those who are following this lecture. So if I run it like this, what do you think the result will be? So I'll pause for a few seconds and you think about the result, then I'll run this code block and you'll get to see the answer. Okay, so have you thought about the answer? So keep it in mind and let us run it. So you will see that it is actually returning array of all elements being nothing, but it is printing all the perfect numbers accurately, as we have seen in this case also. It is evaluating the print function correctly, but the return value is nothing for all case, because when when it is running the println expression, it also returns nothing. So since this is the last expression that it is going to run, or this one, depending on whether this if block is being executed or not. So both of them are returning nothing value. So this function will always return nothing. So this is not very helpful as a return value. So that's why we changed our function in such a way that it returns true or false. Okay. So with that, we have solved all the problems, and I think we are over the 2 hour mark now, or very close to it. So let's conclude this lecture by revisiting the things that we have learned in all the previous lectures. Okay, so this will conclude our basics of Julia, and we have also touched upon some intermediate stuffs. And from the next lecture, we will do data visualization. So you will see when we are doing this, how all the things that we have learned so far will come handy. Okay, so this is just one topic that we will touch in the next class, and it will take the whole of 2 hours. So let us summarize our learnings till now. So we have learned basics like how to install Julia, how to run commands in REPL and Pluto notebooks. So these points will not be chronological. We have also learned about Pluto's features. We also learned about how to get user inputs in REPL and also in Pluto using Pluto UI. We learned about variables, data types, arrays, array manipulation, concatenation, functions to generate arrays, functions to work on arrays. We learned about conditional statements, iterative statements. We learned about how to write functions. We also did some intermediate stuff like learning about multiple dispatch. Here in functions, we learned about positional and keyword arguments, default values of arguments. We also learned about recursions. We did some basic problem solving session. So let me quickly think if I'm missing something. Yeah. So we have also learned about operators. It can be plus, minus, multiplication, this modulo to the power. It can be Boolean and or not. We have seen conditional or equality checking operation using double equal to or not equal to, less than equal to. We have seen how to check subset of an set or superset of a set. We have learned about the dot syntax, which work on arrays element wise, how this syntax can be used with user defined functions. So I think that covers most of the things that we have learned. And in the next class, we'll do data visualization. Okay, so one thing that I missed here is pretty important. That is, what are packages? Julia's package management system, installing packages. So this also we have learned. We have also learned about the inbuilt package manager of Pluto, and we will do the next class data visualization using a package called plots.jl. So we will start by installing it. There are alternatives, but this is the most used package for plotting. Okay, so with that, let me conclude today's class. I will see you all in the next lecture. Thank you for attending.